Welcome back. Today we will be learning about loops. So before we get started, do read chapter 5 of the textbook. It will give you better context of what we'll talk about today. So far we have learned about statements which you can chain one after another to get a sequence of execution. We also learned about conditional constructs such as if else, and switch, which allow us to selectively execute certain statements or choose alternate paths of execution. With that, we will introduce 3 new constructs for doing looping. So let's get started. In this video, I will introduce the concepts and introduce you to the 3 constructs, as well as talk about certain corner conditions and pitfalls and such. For a practical example, do watch the looping constructs video that takes you through actually writing a little program with all 3 of these constructs and compiling it and seeing what happens. So let's say you wanted to print a set of numbers starting from 1 up till an arbitrary number n. You would need a way to execute a print statement over and over again. And loops help you do that by allowing you to execute statements repeatedly. There are 3 looping constructs, and the most simplest one is called a while loop. They're available in lots of languages, and they look something like this. This should look like an if statement to you. So let's talk about a while loop. So what you have here is a new keyword called while. Next, you have a Boolean expression within parentheses, and then you have a block consisting of a set of statements. So the loop would proceed by first evaluating the conditional or the Boolean expression. If it's true, the statements in the body get executed one by one, right? And then you come back again and you evaluate the expression again. If it's true, you again execute the statement. You continue doing that till the conditional evaluates to be false, in which case you exit the loop, right? So a while loop again executes the statements till the condition becomes false, right? The while loop body can consist of a block which is made up of a set of statements, or it can be a single statement, in which case the curly braces are optional. So let's look at a real example. Basically, we'll be doing what we mentioned here, printing a set of numbers. So we declare our n to be 25, and then we have a variable sometimes called a looping variable. We compare the variable I, which is initialized to 1, to check if it is still less than or equal to 25, right? And then we print I with a printf statement. We have included a tab to create the spacing between the numbers. And then we auto increment I for the next go round. And then it comes back again, it's 2 now, and it checks whether 2 is less than 25, prints it, 3, 4, and it keeps on going till the very last, till it becomes 25. It is the last time it's printed. When it becomes 26, this expression becomes false, and the loop exits. Another example is a factorial. If you remember from your math class, 3 factorial is 3 times 2 times 1, and 5 factorial is 5, 4, 3, 2, 1 multiplied together. We can implement factorial very, very easily by loops, and I've given you this example, and you should go through it and convince yourself that it makes sense. You should also see whether you can simplify it, and a hint would be that instead of doing something like this, you could use an auto decrement. Right? Now you have to be very careful with your loop terminating condition, right? So for example, if you were to go back here, if I had less than here instead of less than equal to, the loop would not terminate in the same way. It would terminate at 24 instead of 25. So there's an off by 1 condition that you could get that you should be careful about. Also, a bigger problem might be is if your condition never becomes false, right? And if I had it the other way, or if I have a malformed Boolean expression, this never becomes false then you would get something called an infinite loop. So be aware of infinite loop. Now what happens when you have an infinite loop is it'll seem like your program is frozen, but it's just looping over one statement over and over and over again, and it will never stop. Your program will never terminate, right? One go around of a loop is called an iteration. So a loop is made up of several iterations. This one would be made up of 25 iterations. Right? So infinite loop, iteration are new vocabulary words, right? So we did a math tester program earlier. Can you imagine how you might have improved the math tester program with loops? Perhaps you could have let them answer one math question and ask them whether they wanted to continue, and then kind of loop over the whole program again. Right? Again, be careful using floating point comparison conditions within the loop condition, because floating point numbers are approximate, and you may not get the comparison that you were expecting. The next construct we'll talk about is a do-while loop, and this is very similar to a while loop. It looks something like this. You have a new keyword called do. You have a block of statements followed by a Boolean condition. And the only difference is the do-while loop will first do one iteration of the body, and then the condition is checked. If it's true, then you repeat. If it's false, the loop terminates. Note that there is a semicolon required here that wasn't there in the while loop. That's for a way for the compiler to be able to tell where your do-while loop is ending, right? You can again have a single statement in the body of the do-while loop, or you can have a collection of statements with curly braces. Okay. Now, why would you have this? Is sometimes they're more convenient to use than a while loop. For example, if you wanted to prompt for a value and make sure that it is positive, so you would want to prompt first and read a value before determining if the value is valid. And if it's not valid, you would prompt them again. So you could keep on doing till they actually enter a valid value. So it's very useful there. Right? Very often we loop over a particular number value, such as we did earlier, where we were printing numbers from 1 to n, right? And the loop looks something like this. For that, it is sometimes more natural to use a new construct called a for loop. So you notice we were doing a couple of things with the earlier while loop. We were initializing this value I. We were using I to do a check, right? And then we were incrementing I in the body of the while loop. This can be more naturally represented with a for loop that looks something like this, where you have new keyword called for, and the initialization, the check, and the increment are included in the parentheses and separated by semicolons, and then you have the body following that. So it is a very nice and natural way to represent a loop that is looping over a particular number value, right? So in its general form, it would look something like this, where you have for, and in parentheses, you initialize your control variables, and then you have your check condition, and then you update those control variables, and then the body is made up of the statements, right? So again, this can be made up of a single statement or a collection of statements, right? And if you have a single statement, you do not need the curly braces, right? There must be the parentheses after the for loop, right? And in it it contains the 3 items. It is best practice to declare and initialize the control variables right within the first section. So previously, for something like this, you would have to have declared I before the for loop, but here you can include the declaration right in there, right? I've given the factorial example in a for loop, and it's much more natural and much shorter to represent factorial here. So do go through it and convince yourself that it actually indeed works, right? Of course, you can have multiple control variables. You can have I and j, and you can use both for the check, and you can update both of them. Now you notice the Initialization is separated by a comma, and also the updates are separated by a comma here, right? We can have nested loops, so you can have for loops within for loops. That's perfectly okay, but be really careful, right? Something that might look convenient could give you performance problems. For example, we have 3 nested for loops that go from 0 to just under 10,000, right? And even if the statement we have here took a microsecond, which is a millionth, a microsecond is a millionth of a second, this whole loop construct will take you 227 hours to complete. So this can really add up. It's powerful, but be careful of the performance implications, right? Now you can use a break statement at any time. We saw the break statement in Switch to exit out of a loop. You can test for some condition and follow that with a break, with a if some condition break, and we'll just basically exit out of the whole loop, right? Another statement, the continue statement, can be used to just exit the current iteration and go to the next iteration. So do try those two. There is a difference. Break will get you out of the whole loop. Continue will just get you out of the current iteration. Do note that for, do, while are reserved words, so you can't use them to be as variable names, right? Be careful of floating point numbers in the Boolean conditions for any of these, because floating point numbers are approximations and you may not get the value you think you're getting, right? Be careful of infinite loop, and be careful of off by one conditions that we talked about earlier. Now earlier we had shown you how to use input redirection, right? Whereas instead of taking input from the keyboard, you were taking it from a file. We're going to extend that with something called output redirection. So instead of printing to the terminal, it is basically dumps the output to a file, right? Now, of course, you could combine both of these. You could take input from a file and send the output to another file. Right? That is it. Do watch the detailed video that takes you through examples and actually compiles them. All right. I will see you next time.